Hello everybody, welcome to another tutorial on linear algebra. In this one we're going to solve an exercise that you might also find in this form in your homework. This is the following. Suppose we have vector spaces, let's call them A, B, C. So we have vector spaces A, B, C. And we have linear maps, F and G. So F maps from vector space A to vector space B, and G maps from B to C. And these two are by assumption linear. So what we want to prove, what we need to prove in this exercise is that the composition of these two maps is also linear. So that's a general fact that the composition of linear maps is linear, and this is of course a fact that you will use over and over again in your further study of linear algebra. So let me write this down. We want to show that that G after F, so this is G composed with F, is linear. Okay, so proof. What do we have to show? Remember, for linearity of a map, we have to check two things. First, we have to check that if you apply a map to a sum of two vectors, then this is the same as if you first apply the map and then sum the images. And also you have to check that if you apply if you multiply a vector times a scalar and apply your map, this is the same as first applying your map and then multiplying the image by this scalar. So let me write this down. What this translates to in our case. So we have this map G, F, and we apply this to a sum of vectors. So X is a vector in A, and let's say Y is also a vector in A. And for linearity, we want to show that this is the same as G after F of X plus G after F of Y. And we also want to show that G after F of lambda X is the same as lambda times G after F applied to X. So these are what the two axioms for a linear map translate to in our case, in this example. So let's do this check. So let's first do this number one. So we want to show that G after F applied to X plus Y is this here. Is this right hand side? But we already know that G and F are linear. Remember, this was our assumption. So let's use this assumption. Using this assumption, we can write the following. G after F applied to X plus Y. This is the same as G after F of X plus F of Y. You might write it as this. This is because F is linear. And now we use that G is linear to conclude that this is the same as G after f of x plus G after f of y. And now this concludes this part of the proof. We have now shown that this first axiom is fulfilled by our map F. So this was number 1, and now let's check number 2. So we want to check that G after f of lambda times x is equal to lambda times G after f applied to x. And well, we just use the same argument that we have used in number 1. Namely, we use the linearity of the maps f and g. So G after f applied to lambda x is the same as G of lambda f of x, because f is linear. And now because G is also linear, this is the same as lambda times G after f of x. And this concludes the proof of this exercise. Thank you for watching. See you next time.